Good evening, my 11th standard warriors. Welcome to session number 3 of Work Power Energy. Today we are going to talk about potential energy and mechanical energy conservation and some amazing applications of that. This is Shreyas here. Those of you who do not know me, and I am the physics master teacher, and I am not just on YouTube but also on the Vedantu platform. Not just that, I take up my regular batches, I have my special courses which you can definitely enroll into. And guys, I have been teaching for a very long time, so don't be afraid. Let's rock it together, because I want you guys also to get into IITs, NITs, BITS and all the top-notch institutes, and let's study together for JEE 2023. Let's crack it, guys. And if you want to know more about me, you can definitely follow me on my Instagram handle. And welcome aboard everyone. This is the schedule for this week. So we are doing potential energy, mechanical energy conservation today, then potential energy curves, stability and some problems, okay? And then we are going to go to the final Menti quiz and some additional problem solving session. That's going to be on Friday. So lots of sessions lined up for you, and you can get the PDF and all the important updates on our Telegram channel. So do not forget to check that out as well. All right. Hello Jayawant, hello Saja, good evenings, he says. And maybe I can just pause this a little bit, and probably, yes, let's see when all are chatting out here with all of us. Maybe I can just refresh it. Okay, yes, there we go. Wow. Hi Ria, hi Suji Mama, hi Aditya Ram, good evening. So looks like okay, somebody is rushing from Vani Mam's class. So people are confused now what to do. Vani Mam's class is also at 7 o'clock. Shreyas Sir's class is also at 7 o'clock. Guys, attend everything. But make sure that whichever class you skip, at least watch the replay, okay? Just do that. Okay, so hello Ajo, hello Srimati, Siva Kumar, my god, we have Baratonians also out here. Hello Paulimi Pore. So, oh my god, somebody is from class 8. Hello Chitra, hello Pushpak, hello Gobind. Welcome Ishpreet. Okay, now let's also check how many of you have also done the homework from the previous video. This was lecture number 2, work kinetic energy theorem. And let's all see who and all have done the homework. Very good Ishpreet, very good Shreya, the inquisitive mind. And then we have Arox and we have Saja. And when I start to solve the questions of HCV, after solving one problem, I'm getting stuck to solve the next problem. Is there any way to do better? So can you suggest me something? Well, Shreya and all the other people, let me tell you, if you are getting stuck, okay, in any problem, there is one micro course of mine, which is HC Verma micro course for solving all the problems. So first of all, get enrolled into that. Number 2, all the problem solutions are over there. Number 3, in our doubt app, we have a facility where you can ask to our physics doubt experts a hint for solving the problem. Very often you do not need the complete solution, you just need a hint. So in our doubt app, there is a facility you can ask a hint and then solve the next thing. Ask a hint and then solve the next thing. And it is a continuous chat which you can go with. So that will probably definitely help you. And I think EGL and Shalini and Mansi, which book is best for JEE Advanced for PCM? Well, that's Erodo, HC Verma, previous years, D Mukherjee. These are all the top books. Okay, Ankit, PYQ is important. Very good Swarlini, very good Harita, very good Harshal, very good Gauri Shankar, and AV Thamisian Gaming. Okay, so very good guys. So let's begin with our today's session. So let's begin, guys. So let's first talk about potential energy and what is, stored form of energy. So thank you for all the love, Abhivya from Kerala. And guys, if you have forgotten to smash the like button, please do that right now. And yes, if you have forgotten to hit the subscribe button, also do that right now. Okay, so lots of likes should come up and lots of comments after the video ends. I want it. All the homework answers should be posted in the chat box. So let's begin, guys. For all of you, what is the example of a stored form of energy? So there are different ways in which you can store energy. Even a battery stores energy, but those forms of energy which can store and do mechanical work, all right? So they are able to perform some kind of work that is called as potential energy. Example, this one over here. You take a ball or a rock or a book or a pen or anything on top of something, let's say a wall or a tower, and you leave it. You see that some amount of work will be done by the ball because it will gain some kinetic energy. You can use that kinetic energy in doing some work. So, there was some energy stored. That stored energy got converted into kinetic energy. Similarly, somebody is remembering bio and saying starch in plants. I will also say fat in human body. Yep. So let's get going. Now, another stored form of energy is this bow and arrow. So you can see this string, all right, has stored that energy, and that stored energy goes into that arrow. You can see that very, very clearly. And there are many more examples that I can think of, like a spring which is compressed also stores energy. I can take charges and store energy. I can take magnets and store energy. So you can see all these stored forms of energy is nothing but called as the potential energy. Yep. So what exactly is potential energy, guys? This energy is nothing but an energy which is, in the stored form. It is stored. Okay. It has some ability to do work. It has ability to do work. And all right, this is energy. That means it will be a scalar quantity. All right, it has to be a scalar quantity, and the units of that will be joules, that is in SI unit. And if you are using CGS unit, then it will be ergs. There are more units, but right now you can just learn about joules and ergs. That's enough. And 1 joule is 10 to the power 7 ergs. That's a standard value. Now, this stored energy depends on many things, on how the system is configured, how the system is right now, where and all you have kept those bodies or those things. Example, how much is the spring stretched? How much are the number of turns? How stiff is that spring? All these terms define how much energy is stored in that particular system. Same way, when you take a mass and lift it up, how much energy is stored depends on that mass. How far have you separated from the surface of the earth? All these things together define how much potential energy is stored. So this stored energy depends on the configuration of the system. I hope all of this makes sense to all of you. Yep, configuration is important. Very good. Yep. So having said this, let's move ahead to the next point. So let's just probably see all of this. The energy possessed by any body by virtue of its position or configuration is called potential energy. It is the stored form of energy. It is a scalar quantity. SI unit is obviously joules. Now, there are some more things which you definitely wouldn't have learned in your 9th or 10th grade. That's something what I want to discuss today. Is potential energy significant? Well, very important question, Saja. Actually, you will learn that right now in probably 1 or 2 slides. Is potential energy significant or not? I'll talk about it. But before going there, help me understand this. Do you like to have very high potential energy, or do you like to have very low potential energy? Or any object around you, does it like to have high potential energy, or does it like to have low potential energy? You'll be like, sir, if I have very high potential energy, then won't it be good? Because I have more energy stored and then I have more ability to do work. Well, you're partially correct, but that's not how things work in physics. In physics, when you have more potential energy, you definitely don't like it. It's like, imagine stretching a bow and arrow. The stretched bow definitely doesn't like its current configuration. It wants to be relaxed. It wants to chill out. It wants to come back to its original length. So it tries to minimize its potential energy. Same way, very good Tejasri, correct, it's low potential energy. Very good Salva Kumar, excellent, no Suchi Mama, it is not high. Same way, if you take a ball up, it is going against its will. When you take this ball over here, high potential energy, it does not like it. This red ball will be jealous of this blue ball because this blue ball has low potential energy. This doesn't want to be here. This wants to be here because had there been a surface which directly connected these 2 points, this red ball would have immediately slided down to this blue ball's position. So definitely this red ball is not very happy. In fact, this blue ball out here is little bit happy out there. Now you will ask, sir, is this blue ball happiest out of all the balls available in the world? Well, definitely not, because there might be a ball even below this. Maybe you have a ball somewhere over here, and that ball will be even more happy. Probably it will be crying out of happiness. So the more lower you go, the more happy you get, and the potential energy decreases even more. I hope that makes sense. So this potential energy is something which nobody likes. Everybody wants to lower their potential energy. Will potential energy depend on height? That's wrong, Harita. Potential energy does not depend on height. Potential energy depends on the configuration. Gravitational potential energy depends on height. Spring potential energy depends on extension. So different forms of potential energy depend on different things. Gravitational potential energy depends on the separation between the masses, and it so happens for a mass on Earth, it obviously will then depend on height. I hope that makes sense. So this is the most important diagram that you should know. When you are sad, that means you are high with potential energy, and then you become really happy. So this is low potential energy. So every system tends to go from high energy to low potential energy, from sadness to happiness. So that's how you decide whether something has more potential energy or something has less potential energy. I hope that makes sense. Just like backlog, yes, Zaira. Yes, it depends on position. What is configuration? Configuration, Salva Kumar or Suchimama, I think I just mentioned about it. How have you placed the system? How much it is stretched? Where is the mass? How much is the mass? Where is it? How much is the stretching of the bow? Which material is the bow? So this is basically the configuration. What is the situation? The situation is synonymous with configuration. Okay, Raji Pratap Jadhav, yes, you can clear all JEE. Definitely start watching my nurture classes. You can clear all your backlogs. If you don't do it now, you will definitely not clear it later on. Potential energy of a system always tries to reduce itself when left freely. So if you leave this ball freely, it will definitely try to lower its potential energy. Keep this in mind. Okay, now going to the next part. What are the different forms of potential energy? Come on, let me know in the chat box right now. Prashant, I have already done easy kill topics for JEE Mains 2022. You can check out my past videos. Just search for strategy JEE 2022 Shreyas Sir. You will get it. Okay, so P is equal to mgh? No, that's wrong. Neeraj Chopra, that's wrong. If you have learned it somewhere, P is equal to mgh. Let's flush it out of your head. I will tell you the correct definition of that. Okay, so what are the different forms of potential energy that you have heard about? One, obviously you would have heard about gravitational potential energy, spring elastic potential energy. Yes, correct, Tejasri. You would have also heard about electromagnetic potential energy. Correcto. All these are the different forms of energy. Now try to find some common link between all of them. Try to find, okay, dam storing the water, that's again gravitational potential energy, by the way. Okay, so what is common between spring energy, between electrostatic energy, magnetic energy, gravitational energy? Is there something which is common? Oh, potential is common. No, I'm not talking from English sense like, sir, everything has the word potential, sir. So that means potential is common. No. That's not what I am saying. Okay, wow, Neeraj Chopra is also attending my class. I'm very honored. Yep, thank you. Okay, so Neeraj Chopra, show your killing skills. Show your javelin skills. Come on. Let's see. Well, it's not about the work done, velocity 0. No. Try to recollect what you have learned from the previous chapter or the previous session. I told you about conservative forces and non-conservative forces. Non-conservative forces, evil forces, they do not do zero work. Things like normal, friction, tension, non-conservative. Things which are conservative forces, gravity, electrostatic, spring, magnetic, all these are conservative forces. Reason, they do zero work in a closed path. So that's what is special about all of them. So yes, and the work done is also independent of the path. Yep. So a lot of people think that the definition of conservative force is that the work is independent of the path. No, that's not the definition. The definition of conservative force is the work done is zero. The work done is zero in a path, closed path. The consequence of that is that the work from A to B is independent of how you go. And that's what I proved it in my last session. Hence, okay, Jayant will talk about it when we talk about magnetism someday. But understand that's what is common between all of them. Conservative forces. So you will always see potential energy associated with conservative forces only. Yep, that's right. Gravitational, elastic, spring, electric potential energy, it is only for conservative forces. Why is it for conservative forces only? There is a simple reason for that. If I take a block up, gravity will do some work. Now when I take the block down, again gravity will do exactly opposite work. So the total work done to bring it back to the same point will be zero. That means whatever energy gravity sucks and stores, it will give it back faithfully. Whatever energy gravity stores, okay, while going, let's say, upwards, it will give it back as it is without commission. Friction is not like that. Think about it. Imagine you had a block over here. You move it here. Friction will act like this. Friction will do negative work. Now, again, when you bring that block like this, friction will act this way. Again opposite. Again it will do negative work. So the total work done by friction will be negative plus negative, which is obviously negative. Negative plus negative is obviously negative. So it has not done zero work. So friction cannot store energy. It cannot say that, you cannot say that, okay, when you take this block over here, friction has done negative work, it has sucked away the energy and it has stored it somewhere. Because had it stored it somewhere, then it should be able to give it back. But friction cannot give back, normal will not be able to give back, even tension won't be able to give back. But spring, gravity, electric forces, they can give back the energy as much as they store when you bring it back to the same point. Hence you see conservative forces, alright, they do not have GST, they do not have service tax, they do not cut any taxes out there while they do some work. So they are able to store and restore faithfully. That's why you will see potential energy is only associated with conservative forces. Is it clear? Cyclic process, you can think of it in that way. Yep, you can. Yep. I hope this is clear. Yes. So gravity is like you, but friction is like us. Say special recipe. Oh my God. Okay. So special recipe. I hope someday you become conservative and you develop that potential energy and you crack using that potential energy your JEE examination. All right. Shrimati says clearo. Saja also clearo. Okay. Selva Kumar, it is there, bachas. Projectile motion is there as 2D motion. You will not find a playlist called as projectile motion. That is stupidity. A lot of people teach projectile motion. Projectile motion is not a chapter. 2D motion is a chapter. Projectile motion is a part of 2D motion. So a lot of people think 2D motion means projectile motion. No, it's a special case of 2-dimensional motion. So check out the playlist of 2-dimension. Okay, moving on to the next part. Reference potential energy. Now this is very important point. Okay, let's see whether you can answer this. Okay, let's say I have a block, okay, of mass m and it is placed on the ground. If I ask you what is the potential energy, what is the answer? Let me know quickly in the chat box. Okay. Hello Kiran Kumar. Oh my God, Ninja Warrior, old Ninja Warrior. Why did you change your name? Okay. So yes, definitely you can solve Tatva Mangalam Subramani MG. Hello Kumar says MG. Zara also says MG. Okay. Thank you Dheeraj so much and I hope you continue learning. Wait, I'm asking potential energy, guys. Mg is a force. Be careful. Mg is a force. How can weight mg be the potential energy? Think about it. Circular motion will start later on, Abhiram. Okay. So, hello Chuto, Capfo, welcome. Molish says 0. Harita also says 0. Tejasri says 0. Well, now you guys are telling it is 0. Well, I'll tell you what. The answer is not known. Yes, the answer is not 0. In fact, it is unknown. You'll be like, what the hell? I thought in 9th standard in my school, I was just taught on the ground the potential energy is 0. When you take this block at some height h, then the potential energy is mgh. That's what I was taught. Guys, that is wrong. That is wrong. Potential energy can be 0 anywhere. Don't believe me? I'll make you believe this. All right. It's up to you where you want to take it as a reference. Let's say I define few lines. Okay. Let's say I define few lines over here. And okay. Now, first time, okay, this block is over here, let's say. Okay. And when it is here, taking this as 0 joules, this is my reference, understand that? So if I take that block, okay, if I take that block over here, okay, if I take that block over here, let's say the potential energy becomes, I don't know, 20 joules. And when I take the same block over here, let's say the potential energy becomes, I don't know, 30 joules. Okay, so with respect to 0 joules, it becomes 20, then it becomes 30. Now somebody says, no, wait, this is my 0 reference. So he takes, this is my 0 reference. He takes this as his reference. So for him, this body has 0 joules. If you take it below, then the potential energy will become minus 20 joules. And if you take it on the top, then it becomes plus 10 joules. For this guy who took this line as 0 joules. For another person, he'll be like, no, this is my 0 joules. This is my reference 0 joules. For him, when he brings that block, same block over here, then the potential energy will be minus 10 joules. And if he brings that block over here, then it will be minus 30 joules. What you are seeing over here is that the value of potential energy is insignificant. Somebody was just asking it some time back. No, understand, the value of potential energy is of no importance to us, but what is important to us is the change in the potential energy. So you can take any situation, be it here, or there, as 0 potential energy, and you can talk about the relative potential energy with respect to that situation, which is called as the 0 reference, where you are assuming it as 0. You can see, no matter what reference you take, the change in the potential energy is what is important. So I will write this statement. Potential energy is not significant. Okay, is not significant. But what is significant? Change in the potential energy is significant, because that's what matters to us. It's significant. Okay, and the value of the potential energy, you can change it as per your own convenience. So you can choose any 0 reference as per convenience. Okay, as per convenience, remember that. Okay, so 0 reference is that situation which has 0 potential energy. Is that now clear? Everybody clear? Ankit, don't worry bacha, someday you will be. In fact, I pray to God that you become even more intelligent than me and you continue doing and you do some really great work no matter which field you get into. So then, does the potential energy depend on the 0 reference? Yes, Harita. So somebody might say a block kept on earth has 0 energy. He is right. Somebody might say no, the block kept on earth has minus 100 joules. He is also right. So everybody might have different reference, but no matter how many people you bring in, every person might have different 0 reference, but all of them will agree upon one thing. The change in the potential energy for all of them will be the same. Did you understand? The change in the potential energy for all of them, no matter who takes what as the reference, will be same. That's something that everybody will agree upon. I hope that is clear. Thank you for seeing all my physics videos. Thank you, Jesus child. All right, yep, yes, crack with Gokulnand. The change in the potential energy will be the same. Very important question, Neeraj Chopra. Okay, I like your name, bacha. So how do you calculate this potential energy change? Don't worry, we are going to come to that. Okay, so the change in the potential energy is what matters. It can be assumed to be zero anywhere depending on the situation. Like an unstretched spring, you can assume it to be zero potential energy, and a stretched spring will have certain potential energy U. Oh, by the way, U is generally the symbol for potential energy. You might find some books using PE or P, but P can be often confused with momentum. And if you want to use just one variable, just use the symbol U for potential energy. Now, you might be wondering how to exactly calculate this potential energy. Well, there is a formula for that, and I will be talking about it. Okay, just ignore this part for now. I'll show this to you. This was not supposed to come up so early. Okay, just ignore this. How do you calculate this potential energy? Observe. Yes, there are playlists for all the videos. In our playlist section, you will see 11 standard videos separate, 12 standard videos separate, chapter wise videos, everything is there in the playlist. Okay, now just imagine, you have some block, there is some block, and you take it up. Okay, now when you take it up, gravity is downwards, so we all know mg is downwards, displacement is on the in the vertically up direction, so the work done will be obviously negative. So if I ask you what is the work done by gravity, work done by mg, obviously it will be negative. Let's just assume for namesake it is 5 joules, minus 5 joules. Now try to think, what will gravity do by sucking away that 5 joules of energy? What do you think it will do? Yes, what do you think it will do? What do you think, guys? Come on. Jayant, no bacha, it's perfectly fine, because I don't really think that center of mass should have started by now, because we have started very late because COVID situation. You guys passed out just recently, 1-2 months back. You guys just entered into college. So had you guys passed out and written your 10th board examinations by March, I would have been probably doing rigid body mechanics by now. But situations have changed, right? So you should be considerate towards others. You should understand that a lot of students do not have that kind of services and that kind of luxury to start everything beforehand. A lot of things are there. Things have gone very bad in the past few months. You should be understanding all of that. Okay, all right, chalo, let's see. Okay, special recipe. Okay, so what do you guys think? What do you think this minus 5 joules will do? What do you think, where will this minus 5 joules will go? Yes, this minus 5 joules will go as a stored form of energy. Yep, it will go as a stored form of energy. In fact, the potential energy will increase by 5 joules. So gravity took that energy and stored it. That's what. So instead of using the word P, you can also use the word U, and to give it a subscript, I will put gravity over here. Change in the gravitational potential energy will be 5 joules, plus 5. Now just imagine this same mass, after reaching the top, let's say it comes back. The displacement is here. Obviously, mg is also here. So what is the work done by mg? Obviously, the work done by mg now will be plus 5 joules. How will gravity do work? How will that gravity do work? Because it had some energy stored. So from its bank of potential energy, it will withdraw 5 joules and it will do that work. So gravity is able to do that work. So the change in the potential energy, gravitational potential energy, will be negative 5 joules. I hope this makes sense. Yep. So now what happens is that you can clearly see there is a relationship between work and delta U. What is the relationship between work and delta U? Obviously, they both are opposite in sign, but same in magnitude. So that's what you will see. Work done by gravity is negative of delta U of gravity. Same way, I can also tell you for spring, for electric, and for any other potential energy. You will see that the work done by that conservative force, gravity is a conservative force, okay, will be negative of the change in the potential energy of that conservative force. If it is gravity, it will be gravity. If it is spring, it will be spring. If it is electric, it will be electric. If it is elastic, it will be elastic. So work done by conservative force is negative delta U. So that's what you will see over here. Work done by conservative force is minus delta U. Put it in your head, let it be there in your head. Yeah, that's very, very important. I hope this is clear. So how is gravity produced, Selva Kumar? That's nobody knows. It's just produced by masses, that's all. It's like asking, why do two charges repel? Why don't they attract? It's just the way it is. That's very fundamental law. Nobody can prove the fundamental laws unless you win a Nobel Prize and then you prove it and all of that. Okay, chalo, let's get moving. Now, we all know what is the definition of work. Work is nothing but integral f dx. So if you want, you can put integral f dx is minus du. So if you want, you can replace this with integral f dx will be minus change in the potential energy, because that's my definition. Keep this in mind. Now, it's also very important for you guys to remember that the work done by conservative force releases the potential energy. You can see that. You can understand the meaning of this line exactly over here. The work done by conservative force. How much? 5 joules. Gravity did that work, goes in releasing the is coming by releasing the potential energy. That's why you will see minus 5 joules. That's why you will see minus 5 joules. I hope that is very clear. Yep. Such a rocket propulsion is not a part of JEE, but I'll be teaching it as a separate entity sometime later on. It has been deleted from the JEE syllabus. Let me tell you that. Okay, cool. Thank you, Usha Devi. Okay, so Shukra, I will be talking about how plane lifts in the fluid dynamics chapter, so wait for it. Okay, so it also uses Newton's laws and it also needs Bernoulli's principle. I'll be talking about it then, so hold on for now. So now going to the formulas. If you go by the formula, right now this mass is at m, mass m is over here, and then you lift it up to a higher level. So if I take the ground level as 0 reference, if you take it as my 0 reference, then you can find the potential energy at any height by just the definition. What is our definition? Work done by conservative force is minus delta U. So over here, the work done by gravity, okay, work done by gravity is minus delta U. That means final minus initial potential energy. Now when you take it from here to here, okay, the displacement is upwards, gravitational force mg is downwards. So the work done by gravity, if you take it up, how much it is? It is minus mg into the displacement, which is h. See if this makes sense. Why is it negative? Because gravity and displacement both are opposite. Okay, this will be final potential energy is nothing but U. Initial potential energy is nothing but 0. Why? Because I assumed it to be 0. Okay, so minus minus goes, so therefore U will be equal to mgh. So now understand, potential energy is mgh relative to 0 potential energy. This is not the true value of potential energy, because the true value of potential energy does not have any meaning. It's always the relative potential energy which has meaning, because every time what matters is the changes in the potential energy. I hope this makes sense. So that's how you get this formula mgh. Is that now clear? Yep. Is that now clear? Hello Samim, welcome aboard. Welcome everyone. Okay. So I hope this is also clear. Can we go ahead to the next part? Okay. Can the work done by non-conservative force change the mechanical energy? Jagdish will be talking about it next time. Today we will be talking about, first of all, what is mechanical energy. I have not even taught that. First, let's talk about it. Okay, so the gravitational potential energy at height h with respect to 0 reference is mgh. With respect to. Same way for a spring. You can talk about the potential energy. How? Look at this quickly. If the spring is unstretched, the potential energy is 0. This is my 0 reference. When it is stretched by x, then how do you find it out? Well, the work done by the spring force is equal to the negative change in the spring potential energy. Now what is spring potential energy's change? Final, which is U, minus initial, which is 0. Final is some U, initial is some 0. It's 0 reference. Work done by the spring? Well, I can calculate it very easily. I'll tell you how. Remember, if I draw a force versus displacement graph, okay, the force versus displacement graph for a spring, how will it look like? It will look like this, because F is equal to Kx magnitude wise. This is just the magnitude. So if I consider the area, what will that area give me? That area gives me the magnitude of that work in this case, because the force is also the magnitude. Here, this is the magnitude of the force. What is the base? X. What is the height? Kx. So what is the area? Area is half base into height. Height is force, which is Kx. So it will be how much? It will be half Kx square. That is the magnitude of the work. Is that clear? Is that clear? Yep. I just derived it, Jayant. I just derived it graphically. You can integrate it and also get it. Kx dx integral. Kx dx integral will be Kx square by 2. That's it. So without using integration, I derived it. What more you want, bacha? Hai na? Great. It is not half Kx, it is half Kx square. Okay. So, very good. Very good. Now, understand, guys, very important thing. When you substitute that over here, do not put just half Kx square. Reason, when you are stretching the spring force is behind, extension, displacement is this way. So both are opposite to each other. The magnitude was half Kx square. You think whether it is doing positive or negative work. Is the spring doing positive or negative work while you are pulling this mass over here? Come on, let me know in the chat box. Yep. Think and tell me. Yep, now we are coming to the sign. Now understand this will be minus. Yep, because the displacement is towards the right and force is towards the left. So a lot of people remember work done by spring is minus Kx square. No, don't remember it like that. Remember the magnitude of the work is half Kx square. The sign, you know how to get it. If force and displacement same direction, positive. Force and displacement opposite direction, negative. So that's how you remember it. Do not remember half Kx square, sir, whether it is minus half Kx square, sir, it is plus half Kx square. No, magnitude is half Kx square. Sign, figure it out by looking at displacement and force. Minus minus cancels. So potential energy is just half Kx square. That's it. That's the answer. Very good. Excellent. Thank you, Kumkum Rawat. All right. Yes, crack with Google now. That was coming to minus half Kx square. Yep. So now you have memorized this formula. Very good. Very good. Excellent. So remember this formula. Now let's start with some questions coming up on your screen. Potential energy is half Kx square, where X is the extension, K is the spring constant. First question coming up on your screen right now. Which of the following systems the potential energy decreases or increases? Okay, think for each one of them. For option A, is the potential energy increasing or is it decreasing? For B, is it increasing or is it decreasing? Put up all the 4 answers for all the 4 options down there. Come on, think about it. What do you think will happen to the potential energy? Will it increase, will it decrease, or will it remain same for each one of them? Okay, so somebody is saying for D it decreases. Jagdish, you have to tell me for which one does it increase or decrease? Yep. So compression or elongation to the natural length, it is, yep. From the natural length, yes, crack with Gogulnath, it will be half Kx square, irrespective of whether it is compression or extension, because you are anyways deforming it. So yes, it will be plus half Kx square. Okay, so in the first case, just try to think, when you bring them together, will it become happy or sad? When you bring them, they are trying to repel. They try to repel each other. If they are trying to repel each other, when you bring them closer, they will become sad. They will become sad. If they become sad, that means the potential energy increases. They will increase. Correct. Same way over here. North pole and south pole, obviously they will attract. Obviously they will attract magnets. So when you bring them closer, they are becoming happy because that's what they want to do. So that means they become, what do they become? They become happy. And what is happiness associated with? Decrease of potential energy. I just told you. You don't need to remember any formulas for this. Excellent. Similarly, a spring, you are stretching it. You are stretching it. Stretching it. So what will happen? They will become sad because it does not want to be stretched. It wants to come back. So therefore, potential energy will increase in this case. And in this situation, this mass comes down. The gravity pulls it downward. So when it comes down, it becomes happy. It becomes happy. So therefore, the potential energy will decrease. Correcto. Excellent. That's how it is. Isn't it simple way, guys? Happiness and sadness, that's all you need to figure out whether potential energy increases or decreases. So A and C, the potential energy increases. B and D, the potential energy decreases. That's the answer. All right. Moving on. Okay, somebody thought it was an oxygen molecule. Interesting. Let's talk about this question. It's such a trivial, fundamental question that many people fail to get this question completely correct. Trust me on this. It has got good concept. A body of mass 5 kg moves slowly from this point to this point, and find the change in the potential energy, work done by gravity and work done by other external forces. Very interesting thing. So when you go from point A to point B, what is happening exactly? Well, if you notice, there is some height difference which is created. In fact, it has gone down. By how many meters? By 2 meters. From A to B, it has gone down by 2 meters. So clearly, we can write one simple thing. The change in the gravitational potential energy will be mgh. Mg is G, H is H. But will this be positive or will this be negative? Quickly let me know in the chat box. Suchi Mama says it is decreasing. Okay. Shukra, if you want that, I'm very sorry, bacha. I cannot break the flow for every random thing, but I will try to complete everything as soon as possible, but I cannot assure you I will be able to complete Bernoulli's principle by September. So probably you can check out my flash series videos. I have already completed it. You can check, there is already a fluid mechanics playlist. In that I have completed. Just check that out. Yep, it is negative. Beautiful. So it will be minus 5 into 10 into 10 mgh. Is that correct? Mass of 5 kg. Oh, sorry, H is not 10, my bad, H is 2. Yeah, so this will become minus 100 joules. So that's the change in the gravitational potential energy. Now, if somebody asks you, what is the work done? What is the work done by the gravitational force? Go by the definition. It is negative of delta U by gravity. So, it will be minus of minus 100 and therefore it will be plus 100 joules. That's the answer to the second question. Change in the potential energy done, that's minus 100, and this plus 100 is the work done by gravity. Now the last question, many people fail to answer this. What is the work done by other external forces? Think about it and tell me. Yes, think about it and tell me. Yep. I've taken the height test too. Yes, I've taken the height test too. So think about it and tell me. Yep. What do you think is the final answer? Work done by other external forces. Saja, don't watch the flash series because although I have completed most of it, that was in a condensed form. That is not supposed to be seen if you want to learn everything properly in detailed manner. This year, this is a fresh series, so Saja, don't watch that unless you have a college or a school exam and then you urgently need help from some topic. Otherwise, follow Nurture series, okay? Well, zero. No, other forces, other than gravity. Other than gravity. See, think about it. When you bring it slowly, what is the meaning of that? You're forcefully preventing it from accelerating. Because if this mass is left, obviously it will accelerate by the time it comes here. It will gain some kinetic energy. Don't you agree with that fact? It will definitely gain some kinetic energy by the time it comes here. But the fact that it is moved slowly means that you are preventing it from accelerating. Yes, you are preventing it from accelerating. Now, the moment you are preventing it from accelerating means what? You are absorbing all that potential energy's work done. What did the gravity do? Gravity did 100 joules of work. So, gravity has transferred 100 joules of work and it has taken it has withdrawn from its account of potential energy. It withdrew 100 joules and it did 100 joules of work. Ideally, it would have gone in kinetic energy. But did you allow it to go in kinetic energy? No, right? So what did that external force do? It absorbed that kinetic energy. That means it would have done minus 100 joules. So the external work absorbed all that energy back and it prevented it. It prevented it from accelerating. Yeah. So it's something like friction or some force from outside, somebody is pushing it. It could be air drag, whatever, doesn't matter. So it has taken out that 100 joules and it has basically done minus 100 joules. That's what the meaning is. Many people do not get the signs correctly. Somebody makes a mistake, some or the other person makes a mistake in the signs. That's what you should understand. Everybody clear? Come on, show some love. And if you have forgotten to smash that like button, please do that right now. Moving on to the next question coming up on your screen. Yes, that's the answer. Okay. Shukra, I have done Newton's laws before in Nurture series only, Shukra Zahid. Just check out the playlist of Newton's laws. I have completed Newton's laws, all the 3 laws in detail. Special lecture, just in one lecture I have completed only the 3 laws. Another lecture for pulley problems and another for constraint and so on and so forth. Just check that out. Okay. Sir, is exam will be theoretical? It will be a combination of both, Kumkum. There will be questions. There will be match the following, there will be concepts, there will be logical questions, there will be visualization questions, there will be statements, there will be numericals, there will be, certain things like fact-based questions also. All things will be there. Okay, let's do this. There is a force and the question is, what is the potential energy as a function of x if the reference potential energy is at the origin? The zero reference is at the origin. Okay, let's try and do this. Now force is given and we have been asked energy. How do I relate force and energy? I think I need to start with the work and energy definition. The work done by the conservative forces is negative delta U. That's what it is. Acha. So what is the work done? Work done is integral of force with respect to displacement, and that is minus delta U, which is nothing but final minus initial potential energy. Now I know what to do. Just substitute the value of force from there over here. So what is the value of force? It is 3x square minus 2. 3x square minus 2 integral, and this is dx is equal to final minus initial potential energy. So I'll just put it as U, final I'll put it as U, initial potential energy I'll put it as 0. Now why did I put it as 0? You should understand. This initially it was at the origin. So this is my 0 reference at origin. That's what you should understand. So if it starts initially from 0, the lower limit should also start from the least value of x. If it starts from the origin, what is the value of x at origin? It is 0. Finally, at some x, so this is at some x final, that will be the upper limit, so that will be coming up over here. Okay, that's the upper limit. Now you just need to perform this integration. That's not that difficult. So 3 integral x square dx, 3 is a constant, it goes outside, from 0 to x, minus 2 integral dx is equal to, this will just become minus u. Okay, let's do the integration over here and see what do we get over here. So integration of x square is x cube by 3. So it will be x cube by 3 and upper limit is x, lower limit is 0, minus 2. Integral of dx is just x. So I'll just put x over here, 0 and x as it is, lower and upper limit. Probably I forgot writing it over here. And finally on the RHS, minus u. Now just do the integration. So this will be nothing but first substitute the value of x. So it will be x cubed by 3. Then substitute the value of 0. So it will be just 0. Minus 2. Substitute the value of x. Substitute the value of 0 over here. This will be minus u. Now what do you get? Okay, so this will be 3 by 3 will be 1. So it will be x cubed minus 2x is equal to minus u. Therefore, u is equal to 2x minus x cubed. That is the final answer. Yep. How upper limit comes? See Zaira, whenever you have integration, the lower limit is always or generally the initial value. So initially the potential energy was 0. It's given in the question. Potential energy 0 reference. That means initial potential energy 0 at origin. What does origin mean? X is equal to 0. So initially limit is 0. Finally some value of x. What is the potential energy? That's how the limit comes. I hope that clears it. MD Riyaz, you will find easy to difficult level problems only at one place, that is HC Verma. Number 2, in Tattva module. Tattva module is the module provided by Vedantu which scales up the level of problems from easy to difficult. Yep, 2x minus x cube, that's the answer. Moving on to the next question coming up on your screen, and here it is. Calculate the energy stored in a spring which is having a spring constant of 2 when it is compressed by 5 meters. Achha, how much more work will be needed to further compress it by 5 meters? Let's try to do this. Say, if you have a spring, okay, and let's say you have already compressed it by 5 meters, then it already has some energy stored. Let's say I call it U1. How much energy does it have? Half K. K is how much? 2 into X. X is how much? 5. So 5 square. So it will be nothing but 25 joules. So that's the energy stored initially. Okay, so that is the energy stored initially when you have already compressed it by 5 meters. Now, what have you done in the second situation? How much more work will be done to further compress it by 5 meters? That means the same spring is now further compressed, okay, by more 5 meters. So the total compression will actually be 10 meters. This is the total compression. Keep this in mind. Now the final energy, okay, the final energy which will be stored in the spring will be half into K. Do not put 5. Yes, it will not be 5. It will be 10. Be careful. Yes. Oh no, crack with Gokul nut. It will not be minus 25. It's the stored energy. 25 joules is stored. So it is plus 25 joules only. Be careful. Yes. So this will be 10 square, which is nothing but 100 joules. 100 joules is stored. This also tells you one more thing. For the first 5 meters, only 25 joules was stored. But for the next 5 meters, even more energy was stored. Why did that happen? It happened because spring is not a constant force. Spring force is proportional to x. More the compression, more the extension, more is the spring force. So that's why for the next 5 meters, there was a tremendous increase in the potential energy. So the question is, how much work was done? How much work was done? 100 minus 25. 100 minus 25. This is basically 75 joules. That's the answer. Because earlier there was 25 joules. Now you are storing 100 joules. So you have to do 75 joules to bring it to 100. I hope that makes sense. Very good. Excellent. Marking your attendance, Zayed. Yep, it is not Newton. Be careful, Harita. It is joules. It's energy. Zaira, it's not minus 75 because you are doing work. External force. How much more will be needed? When I say this, it is external work. External work. Please understand. If the question says, what is the work done by the spring? Then it will be minus 75. There will be a change. Spring will do minus 75, but externally you are providing 75. that will be sucked by the spring. That's why minus sign, and it will store it in the potential energy. Okay, okay. I hope that is clear. Moving on to the next question. Yes, 75 joules is the answer. Yep, let's see how many of you get this. Let's get moving to this question. This body of mass 100 grams is suspended, and initially the natural length was 100 centimeters. If you put this mass, it stretches by something, the final length is 120 centimeters. How much potential energy is stored in the spring? Yep, come on, my warriors, think about it. All right. Well, initially natural length is 100. Okay, so this is 100 centimeters. 100 centimeters is 1 meter. This is 120 centimeters. That means it is 1.2 meters. That means this is extension, which is 0.2 meters. Now, when it is suspended, obviously, I do not know the value of K. I need to find that K. So to find that K, I'll use Newton's laws. We know that the weight and the spring force will cancel out each other at equilibrium. Yes, at equilibrium, the spring force will be equal to the weight. Spring force will be Kx, weight will be mg. Therefore, K into, what is the value of x? X is 0.2 is equal to m. What's m? That's 100 grams, which is 0.1 kg. G is 10. So 0.1 into 10 is 1. So this is nothing but 0.2. 0.2 is nothing but 1 by 5. So therefore, K is equal to 5 Newton per meter. Correct? The value of K is 5 Newton per meter. I need this to calculate the energy stored. Now go for the energy stored in the spring. The spring potential energy, what is the formula? It is half into K into x square. So what is K? I just figured it out to be 5. What is x? X is 0.2. Correct? Is it given to be point? Yeah, I just take it as 0.2 square. So I can just write it as 5 divided by 2. 2 square, that's 4. But it is 0.1 square also, to 10 to the power minus 2. So this will become 2, 5 2s are 10, so 10 to the power minus 1, which is 0.1 joule. So that should be answer C, correct? I hope this is clear. So Muthu Kumar, don't worry, even if you have a test, the final test is very important. The final test is very important. Even if your test is tomorrow, I won't be able to complete it, Muthu Kumar, honestly, sorry. Okay? I'm not here to make everybody happy. So guys, if you think that if you have a test tomorrow, I'll be able to complete it. No, sorry, I cannot do that. Because understand, I'm not here for the small term or immediate benefits. I'm here with you till the end, till you write your JEE Advance. I'm interested in that. I want you to get the rank finally. You might score well if I conduct a one-shot series maybe tomorrow. But again, you'll forget it because you have not understood the concepts. So that's why I'm focusing on the long term, and you will realize it after 2 years or maybe 1 year, depending on when you are writing it. Oh, March is too late, bacha. I will complete it before January. Don't worry. Okay, so that's 0.1 joules. Moving on to the next question. Which of the following statements are true? Yep. Which of the following statements are true? Think about it. This is conceptual based, fact based question. You should be able to get this very easily. Come on, my warriors. Which of the following statements are true? At the center of the earth, the gravitational potential energy is 0. When potential energy increases, the work done by non-conservative force is negative. When potential energy increases, the work done by non-conservative force is okay. I think this was not supposed to be non-conservative, guys. This was supposed to be just conservative. My bad. Okay, so ignore this word. I will change it in the final PDF. Okay, I'll change it in the final PDF. Okay, change in the potential energy depends on the frame of reference. Come on, my warriors. Okay, yes, more than one can be true. That's why is are. Maybe, I don't know. Yes, massless spring, so the tension is equal at every point. Yep, correct, Google Nath. So D or C. Okay, always there with you guys. Yes, Salva Kumar, JEE means exam is the final exam. Come on, Muthu Kumar, let's do this. Okay, somebody is saying B and D. At the center of the earth, gravitational potential energy is 0. This is wrong. It may be 0. Is no. It may be. Maybe. Why? Because it depends on the reference. depends on the reference. So guys, understand, I can take anywhere as zero potential energy, so it does not make sense to assume zero at the center of the earth. It may be, it may not be. Okay. When potential energy increases, the work done by conservative force is negative. So work by conservative force is minus delta U. So when potential energy increases, that means delta U is positive. Energy increases, delta U is positive. So work will obviously be negative. So hence this option is correct. Naturally this option is wrong because it says positive. Okay, B. What about D? Change in potential energy depends on frame of reference. Wrong. It doesn't depend. Remember, this is change in potential energy. Delta U is same for all. I just told you. So it does not depend, guys. This is wrong. Okay, this is also wrong. I hope that makes sense. The change in the potential energy does not depend. Correct, Selva Kumar. Yep. So each person might say this is different potential energy, but the change in the potential energy will be same for everyone. That's why only one option is correct. This was a trick question. I just deliberately put R word over here, thinking, making you forcefully think that more than one may be correct, but only one option was correct. And this is what JEE does sometimes. They say it is multiple correct, but they give you only one answer correct. Correct? Let's get moving. So I'll change the option over here, the wordings. It was supposed to be just conservative. Just ignore that non-word. Okay. So let's move on to the next one. And guys, if you have doubts, please use the Vedantu app. Take a picture, send your doubts with our doubt experts, chat with them, ask for hints, check your solutions, and you can ask them doubts right from morning till night. And this is all for free for all the Vedantu Pro students. Let me tell you that. Okay. So from where you took this question? These are all secret, trade secrets. I cannot tell you where I took it. Very secret. So, yep, potential energy does not depend on other things. Yep. Okay. Chalo. So, Ultra Boxer probably should go and ask in Wasim Sir's class only. Okay. Chalo. Mechanical energy, standard. Okay. Now, Anil Kumar, it's Aditya Sir. Aditya Sir is teaching. He's a very good teacher. Yep. If you are considering a drop, please go ahead. And all the other teachers are also very good. Okay. Chalo. Mechanical energy is nothing but the sum of kinetic and potential energy. As simple as that. So let's say there is a bike, or there is a trolley, or if there is a spring, or there is charge, doesn't matter. Everything will have some kinetic and some potential. So the sum, that means potential plus kinetic, is the mechanical energy. That's what it is all about. Okay, mechanical energy is the sum of kinetic and potential energy. That's what you should remember. Now, talking about conservation of mechanical energy. Mechanical energy is conserved when non-conservative forces do not do any work. Yes, they do not do any work. This is very, very important. Only then the mechanical energy is conserved. Otherwise, it is not conserved. Look at this. This ball has a lot of kinetic energy over here. It slows down. It gets converted into potential, partly. There is still some kinetic remaining. And again that potential gets converted into kinetic. So, kinetic decreases, potential increases because it got converted. And eventually potential again decreases, it gets converted into kinetic. All this happened because there was no friction. If there was friction, then probably it might not even reach on the top. Maybe it might just stop over here. So where did that mechanical energy go? It went away against the non-conservative forces. Yes. So does the word conserve refer to not created, not destroyed? Yes, exactly. It is conserved. It is preserved. So when is okay, read this statement as preservation of mechanical energy. When is mechanical energy preserved? Only when there are preservative forces. Okay, I'll give an example. You have that fish, or you have so many dishes, which your mom or your relatives would prepare. You always add some preservatives, like pickles. Yeah, you add some preservatives. Or you might have had those nuggets, or those fries which are stored in the fridge, and then you take it out and put it in the oil fryer, and then you fry it and you enjoy your day. Okay, so all these are added with some preservatives because you have to store it. So the preservative forces, which are the preservative forces? Gravity, electrostatic, spring, elastic. So when these conservative forces are there, then mechanical energy is also conserved. But when friction, normal, tension like forces are there and they are doing work, then mechanical energy is not conserved. As simple as that. Yeah. Where will the sound energy go? It will get absorbed into all the surroundings. It will just fly off everywhere. It will get absorbed into surroundings. So when non-conservative forces do not do any kind of work, these are the destroyers. These are like bacteria, virus, fungus. You take a bread, you do not add preservatives, leave it outside, gone, destroyed. So when you take non-conservative forces and they are doing some work, it's not preserved. And when there are no work done by non-conservative forces, only preserved forces are there, conserved forces are there, then the sum is constant. That's what it is. Conservative does not mean constant. Conserved means constant. Conservative is an adjective given to a force. Surrender. Okay? I hope that is clear. In which type of forces gravity comes? Knowledge facts, it's conservative. Okay, let's start doing some questions based on, conservation of energy. Come on, my warriors. I have some 3 questions, I believe, to solve on this. First of all, read the question and see what is happening. At the bottom of a smooth track, there is a smooth track, there is a mass, it is attached to a spring, all right, of constant K. The block is compressed by X meters and then released. This reminds me of Hot Wheels, and when I tried this out, you get this beautiful looking car and you push it, okay, the spring gets compressed, okay, and then you have this track and then you have this hula loop, so this car goes like that and comes like this. Have you seen that? Have you done this? Probably. Well, you can take a spring, if you have a small car, press it against the spring, make your own track and see how much compression you need to release that car and do that loop, and it will go without falling. Knowledge fact says yes. So better be better. No, I'm not handling the dropper's badge, but there are teachers like me who are handling the dropper's badge. Let me tell you. Okay, so this is something similar to that. Now, tell me one thing. Are there non-conservative forces in this particular system? Okay. When this block goes like this, it goes up. Okay, it goes up. And finally, let's say it goes up till here and it stops. Tell me, while it is going, okay, while this block is going up like this, are there non-conservative forces? Well, yes, it's called Hot Wheels, I know that. Ishpreet also agrees with me. Sai Telgo, fan of Hot Wheels. Okay. So is there non-conservative force? Yes, there is. And you'll be like, which one, sir? Right, come on, there is a normal force. But I'll tell you what, a secret. Normal force is perpendicular to the displacement. So work done by normal is actually 0 because normal is perpendicular to the displacement. Remember, this was a non-conservative force. So if normal is not doing work, evil forces are not doing work, fungus is not there, bacteria is not there, virus is not there, only preservatives are there, conservative forces are there. Therefore, mechanical energy is conserved. That's it. So finally, it goes and stops over here at some height. Let's assume over here, initially, this is 0 reference. 0 reference. Let's just assume this as 0 reference. So think about it. Rajiv Pratap, you are free to leave the class, bacha. Okay. So I can write this as initial potential energy plus initial kinetic energy because it is conserved. What is final? Final will be final potential energy plus final kinetic energy. What do you think is the initial potential energy? Well, there are 2 types. One is the spring and other one is the gravitation. So when you compress it, how much is the spring potential energy? Obviously it is half k x square. What is the gravitational potential energy? Obviously it is 0. Kinetic energy, because you have compressed it and just left it, it has not yet gained the kinetic energy. Yes, it is just 0. Yep. So kinetic energy is also 0. I hope this makes sense to all of you. It's only just released. You have compressed it and just left. It has not yet acquired energy in the compressed state. Eventually, when it goes up, again it has two forms, spring and gravity. Right now, when this block is released and it goes up, the spring comes back to its natural length. So the spring potential energy is 0. Gravitational potential energy is mgh. Gravitational potential energy is mgh. I hope that makes sense. And kinetic energy is half mv square. Yes, that's, oh, no. This will also not be half mv square. This will be 0 because it stops eventually. What's the maximum height reached? So at maximum height, it just reaches, stops, and again it will come back. So when it has just stopped, the kinetic energy is 0. So now you just need to equate them. Therefore, half kx square is equal to mgh. Therefore, h is equal to kx square by 2mg. That's the answer. Everybody clear? Yep. Yes, it's a smooth track. There is no friction. Read this, smooth. Okay. Now you might be wondering, sir, what if there was friction? We'll be doing those kind of questions in the next class or so. So where we'll be having non-conservative forces doing some work. Don't worry about it. All right. Chalo. Let's get moving to the next question. Kx square by 2mg. Here it is. All right. Very good, Srimati. Very good, Ishpreet. All right. Moving on. A body is projected vertically up with certain speed. The ratio of the speed of projection to the speed of projection, speed at a point in its path is 5:4. What is the ratio of potential to kinetic? Interesting question. Let's try to draw the diagram and understand what is happening. So you throw some body up, let's say with speed v1, it goes up, and at some point it has some speed v2, it goes further up and comes down like this. This is thrown from the ground level, let's say. Now, according to the question, the ratio of velocity of projection to the velocity at a point. This is where you project it. This is where you project it. This is some point basically. Okay, and let's say this is height h. Now, what is given in the question is v1 by v2 is 5/4. It's given. Speed of projection upon speed at some point is in the ratio of 5:4. Initial speed will be more, final speed will be slightly less. Okay. Now, think about it. Yeah, Salla Kumar, I know the tracks look irregular, but the tracks are smooth. Okay. Yes, they are examples of non-conservative forces, Karthik 999. Okay. Now, here is the thing. Isn't kinetic energy equal to half mv square? Therefore, can I say kinetic energy is proportional to v square? Therefore, can I say kinetic energy of 1 upon kinetic energy of 2 is nothing but v1 by v2 square? Think about it. Does it make sense? It is v1 by v2 whole square. Okay, so just substitute the ratio. So what is v1 by v2? It's 5/4. So it's 25/16. That's k1 by k2. Interesting. Now you'll be like, so why the hell did you do this? I'm going to do a simple trick now, because the question reads the ratio of potential to kinetic energy at this point. At this point. Okay. Let's say over here the potential energy reference, if I take it as 0, here the potential energy is U2. Now, can I not just conserve energy? So if I conserve mechanical energy, what do I get? Think. Initial potential energy 0. Initial kinetic energy K1 is equal to final potential energy U2. Final kinetic energy K2. Now I'll be like, okay, what now? Are you going to substitute some values? Yes. How? Over here. What is K1? K1 is 25/16 K2. K1 is 25/16 into K2. Just take this K2 over there. So I can write it as 25/16 into K2. From here, K1 I have substituted it. Will be equal to U2 plus K2. Take this K2 on this side. What will you get? K2 common, 25/16 minus 1 is equal to U2. Acha. Now what do? K2, 25 by 16 minus 1. 25 minus 16, 9. So it will be 9 by 16 is equal to U2. Therefore, U2, bring K2 below, will be 9 by 16, which is exactly what we want. Potential to kinetic ratio at that point. Put 2 is this point, some point. Yep, that's it. As simple as that. How many of you got this? Isn't it a fascinating problem? What a lovely problem, guys. Can we go ahead to the last question coming up on your screen? Let me know, guys, if you're ready. Put some fire, put some smiley, put some thumbs up in the chat box. And if you have forgotten to smash the like button, go ahead, smash the like button also down there. Very good, Esprit, very good knowledge facts. Excellent. 9 by 16 is the answer. Going to the next question. Thank you for all that fire. Okay. Chalo. Here is the next question. This is a very important question. Uniform chain of mass M, length L is kept on a horizontal table with 1/3 its length hanging from the edge of a table. It starts sliding down, and question is, find the speed of the chain at a point when it completely leaves the surface. Selva Kumar, don't worry, bacha, from where I took the problem. Yeah, just worry about solving it. Yeah, okay. Thank you, Srinivasa Chaitanya. Okay, thank you for loving. I know, Selva Kumar, you are very impressed, but let's just do this question. Okay. PCB or PCMB? Take PCB or PCM. Don't take PCMB. Okay, let's solve this. Okay, initially, okay, so what is happening is 1/3 of the length is hanging over here. Eventually, what happens is the entire chain slips down. Okay, so this was initial, this is final. Now I will also take my reference. This I will take it as my reference 0 reference potential energy on the tabletop. Obviously, this length is 1/3 because 1/3 is hanging. So this is L by 3. Finally, when entire thing comes down, so obviously the entire length will be L. Okay. Now, because it is on a smooth table, I think it is missing, but it is, let's assume that it is smooth. I think that word was missing over there. Okay. So I can conserve the energy. So conserving energy, mechanical energy, what I can get is that initial kinetic plus initial potential is final kinetic plus final potential. Fair enough? Okay. CAPFO nurture is a name given to 11th standard. For 12th standard, we are calling it as Pathfinder, just so that there is no discrepancy and there is no confusion. Okay. When you just leave it, what is the initial kinetic energy? Quickly think and tell me. What is the initial kinetic energy? When you just leave it in this situation, when it is hanging, obviously it is 0. Correct? It is 0. Finally, when it comes down, obviously this thing over here gets some velocity, V. This entire mass is coming down with speed V. This slides, goes down, it has some velocity, it has some kinetic energy. So how much kinetic energy it has? It has half mv square. Okay. Now comes this and this value. And this is crazy. Let me tell you. Yes, Srinivas Chaitanya, nurture series is meant for starter and beginner, but start from the starting chapter. So you cannot start from a middle chapter and say that is this for beginner. So start from the first chapter, right in the playlist, right from units and dimensions and all of that. Now let's talk about final energy, then we'll go to initial also. See, whenever you have a body which is distributed, then to find the potential energy, you need to consider it like a point. This entire rod or entire chain needs to be considered like a point. So when you have a sphere, you can make it like a point at the center. That is called as the center of mass, where all the mass is concentrated. Now think about it and tell me, where is the center of mass of this chain? Obviously at the center, right? Obviously at the center, right? Think about it. Yes, it's exactly at the center. And where is the center of mass? Well, that's here. This is where the center of mass is, of this part. So where is that located? Obviously at L by 2. So the potential energy of that entire chain, because it's below, be careful, it will be minus. Why minus? Because it is below. If it was on the top, plus, it's below. So minus mg, and this will be L by 2. That's the catch. A lot of people make a mistake and they write mgl over here. It is not mgl, it is minus mgl by 2. I hope this makes sense. Everybody clear? Everybody clear? Yes, crack with Google. Now this is a very important question. Now comes the initial part. This is where many people make a mistake. Where is the center of mass? Oh, by the way, let me tell you, this much part has zero potential energy. Why? Because it is on the zero reference. Only this much part is below, so that much has negative energy. How much energy? First locate the center of mass. How much below is the center of mass? If this is L by 3, how much is this? That is L by 3's half, which is L by 6. Do you see that? It is at L by 6. Correct knowledge facts. Very good. Very good, Srimati. So it is at L by 6. So this will be, first of all, this is minus. Why minus? Because you're below. And mgl by 6. But there is a catch. It is not m. Like, sir, why is it not m? Guys, whose potential energy are you calculating? You are calculating this hanging part's potential energy. How much is the mass of this? The total mass was m. 1/3 part. This 1/3 part. This 1/3 of the total mass. M by 3. So this will be also m by 3. Yep. Why minus, Selva Kumar? Because you are below. You are writing potential energy of this part. See, when I write potential energy, it's the potential energy of the entire thing. Out of the entire thing, this much part on the reference has zero energy. The one which is hanging, only that has negative energy, just like this one, because it's below the reference. That's why negative. Isn't it crazy? M by 3, guys. Yes, it's M by 3. No, not ML by 3, M by 3. Yes, hello Divya Peter. Now you solve this. This is not that difficult. You can get the answer. Okay, you can get the answer. Solve this. I'm pretty sure you'll get the answer from this. Is that clear? Solving that is not that difficult part. You can check it out. The answer is over here. 2 root 2 GL by 3. Just short of time. That's why I'm not solving it. Else I would have solved it. Okay, so 2 root 2 GL, the entire thing divided by 3. That's how this question is. Now there are 2 homework questions. I want you guys to post up the answers in the comment section below. Yep, this is for NEET 2 Adil. Yep. Okay, no, it's not root 10. Be careful, knowledge facts. It comes out as root 8 and 9 also comes inside. Then you can take it out. Root 9 becomes 3. There's the first homework question. This is the second homework question. Post up the answers in the comment section. Immediately I'm going to check. And if you are interested to check out my batches and you are wanting to learn from amazing teachers like me, you want your doubts cleared and you want an English batch, go ahead guys, enroll right now, because the courses are as low as 3,600 rupees. If you want some additional features like doubt solving and personal mentorship, then go for Classic or Plus version. Classic is the one which most of the people go. Go ahead with it, use the coupon code and you get 10% off. The link is in the description box below. And if you enjoyed the session, do not forget to smash the like button out there. Thank you very much. This was Shreyas here, your physics master teacher, and I was going live. Hasta la vista. See you next time.